Assalamu alaikum everyone. Myself Zaid Ali, along with my two team members Said Faizan and Muhammad Hadi, we are going to represent our discrete structures project, temporal and category based price similarity network analysis using the Pakistan Bureau of Statistics CPI data from 2023 to 2024. Our project analyzes how the Pakistani cities are economically connected based on the price patterns. We collected consumer price index data covering the 17 major cities, 51 products across 7 categories for the years 2023 to 2024. The 7 product categories we analyzed are food staples and greens, meat, poultry, dairy, oils, oil contaminants and sweeteners, fruit and vegetables, non-food essentials, utilities and transport, clothing and other stuff as well. From initial data set of 22,542 records, we cleaned and retained 18,129 valid observation dates and 80% of retention rate. Now I will be explaining the mathematical approach, which approach we uh, take to solve this our project. We applied the min-max normalization on per product basis. This captures the relative price differences. For example, the wheat flour ranged from 1,599 to 3,097 rupees, but at Islamabad it's 1,773 rupees normalized to 0.11, indicating it's relatively cheap for this product. Cosine similarity. We compute the similarity between cities using this formula. This means this measures the angle between price vectors. A value of 1 means identical patterns while 0 means completely different. It's now show the cosine similarity heated map graph. Yeah, on your screen it's 7x7 colored coded matrix showing similarities. We verified 3 key properties. Self-similarity equals 1, symmetry where the similarity of AB equals to BA, and all the values in the range from 0 to 1. Similarity matrix. Briefly, this series demonstrate the actual computed values, constructed graphs. Using these similarities, we construct weighted and undirected graphs as well. Networks, can you show me? Yeah. Display this network graph showing cities as nodes with edges representing connections. We define a relation cities I and J are connected if their cosine similarity is greater than or equal to threshold tau. We analyzed 4 different thresholds: 0.8, 0.85, 0.9, 0.95. Higher thresholds create sparser networks and revealing only the strongest relationships. At tau 0.85, we get tau equals to 0.95, it drops to 49%, showing the threshold sensitivity. Now I will explain the project.
Assalamu alaikum. My name is Sayyid Fizan Haider and my roll number is 24I0803. And now I will walk you through the coding part of this of our project. So thank you, Zaid. Let me walk you through how we implemented this project. So we developed our solution in 7 distinct phases using Python with NumPy, Pandas, and Matplotlib. Importantly, we implemented all algorithms from scratch, no network X or specialized packages, demonstrating our true understanding of the underlying mathematics. So let's go through the all the phases that we coded in this project. The in phase one, we did data loading and pre-processing. We loaded about 22,000 records, removed invalid entries, and applied pre-product normalization. In phase two, we did similarity matrix construction. We built 17 by 17 matrices, one for each city pair across all 14 year category combinations. In phase three, we did centrality calculations. This is where we computed 4 different centrality measures for each graph. So we computed 4 centrality measures, all implemented from scratch. So as we can open the centrality comparison 2024 food staples grains picture. Now this is a 2 cross 2 grid showing all four centrality types. The first degree centrality, the first is degree centrality. This counts how many cities have similar prices. High demand means city prices match many others. It represents typical market conditions. Second is closeness centrality. This measures how easily a city reaches others through centrality paths. We used breadth first search to compute average shortest paths. High closeness means centrally positioned in a network. Third is betweenness centrality. This counts how many shortest paths pass through a city. High betweenness identifies which cities that connect different regional markets. Fourthly, we did eigenvector centrality. This measures influence based on connections to other influential cities. We used power iteration to compute this. High eigenvector means you are connected to the elite network. Now, if we can show the food staples grains CSV file centrality. Now, this shows the actual centrality scores for each city. Notice how different cities rank differently depending on the measure. Multan scores high in betweenness. It's a bridge. Karachi scores high eigenvector. It's connected to other major cities. Um, so if we can uh, see that to get a single influence score per city, we aggregated these measures using weights. So if we can go to the aggregation part, we can uh, we can see the formula where WD plus WC plus WB plus WE is equals to 1. Now, this shows how ranking changes under different weighting schemes. This also shows the direct comparison across schemes and um, and also shows the numerical ranking changes. The rankings can shift 3 to 5 positions depending on weighting choice. This shows methodology matters. Now, I'll pass to Hadi to discuss our results and findings.
Assalamualaikum. My name is Hadi and my roll number is 24I0696. And I'll be covering over our key finding that we found in this project. Now, if you could open the Hasse diagram, it shows the evolution of the network that we analyzed from 2023 to 24 and discovered the fascinating patterns. Now, moving on, if we open the Hasse diagram CSV summary, it shows that 5 categories. The main growth in 5 categories, meaning that the cities became more popular. The food staples and grains plus 100 edges from 25 to 125. Meat, poultry, and dairy it has plus 90 edges. Clothing has plus 84 edges, and non-food essentials has plus 40 edges. Fruit and vegetable has plus 5 edges. Now, if we move on to the oil and condiments and sweeteners part, it has -3. Utilities and transport has -11 edges. The heat map show. If you could open the heat map of the four staples, it shows that the city pairs increase or decrease. Similarly, this tells us that 71.4 percentage categories are integrated. Pakistani market are becoming more unified, especially for basic necessities. Moving on, it shows that Bhavalpur, if you open the CSV file summary, it shows that top 5 initial cities are Bhavalpur, Hyderabad, Quetta, Rawalpindi, and Multan. And Bhavalpur has a remarkable story that it jumps from 11th position in 2023 to first position in 2024, a 10 position improvement. That shows the dramatic shift in our data set. Now, if you just look at the Sihal code, shows the highest influence, gain plus at 0.6, Bhavalpur gained 0.24. Meanwhile, Sakkar dropped 9th position, gain despite the influence, others simply grew faster. We also verified the mathematical properties of temporal relation. We defined relation graph G at year G and at year Y and related to graph G prime at year Y prime if the data set is if the edge of Y is subset of Y prime. And now if you could open the report where there we can see that the properties that were verified, the first that is reflexive, second that is antisymmetric, and third that is transitive. All the 7 categories satisfy the properties confirming valid partial orders. So to conclude all of this, we analyzed over 18,929 price observation across 17 cities verified
71.4% market integration trend, discovered powerful remarkable 10th position rise, confirm mathematical validity through uh, partial order verification. Now, Fizan, could you cover your part of the conclusion?
So yes, we implemented all algorithms from scratch, generated about 95 visualizations and 139 uh, data files, demonstrating deep understanding of discrete mathematics concepts. Now move on to Zahid.
This project shows how the discrete mathematics, relations, graphs, and partial orders provide powerful tools for understanding the real world economical phenomena as well. That's all from our side. Thank you for watching.